Ini kita iya kan dari tadi
Dan agak bahaya.
Mbak. Terus check. Oke, masuk. Aman. Oke, oke.
Good morning, distinguished speakers, respected educator, esteemed guests, and my dear students. It's truly an honor and a great joy to welcome all of you to
Tes. Man. Enggak, tapi
Masih di sini gini.
World Scientific Conference.
Good morning, everyone. First, I would like to express my deepest apologize on the high school scientific conference committee for the delay in starting the webinar. In today's webinar.
A very good morning to all of our distinguished speakers. Thank you for keeping up with us throughout the delay. I hope you're all still as excited as I am because today is packed with energy, innovation, inspiration, and endless opportunity. Welcome to the High School Scientific Conference 2025. I'm Lovely, and I'm honored to serve as your Master of Ceremony for today's event. On behalf of the organizing committee, it's a pleasure to welcome all of you, our esteemed guests, speakers, teachers, and of course, our brilliant student participants to this year's conference. We sincerely hope you're doing well and feeling as enthusiastic as we are to dive into a day full of exploration and learning. We have an exciting lineup ahead: keynote speakers, sharing sessions, interactive discussions, and more. Whether you're here to present, learn, or simply be inspired, there's something here for everyone. Let's make today count. First of all, we would like to extend our warmest gratitude to the individuals who have made this event possible. The Honorable Headmaster of 10 Senior High School Bekasi, Mrs. Dr. Randa Hajar Mukarama MPD, the Vice Principal of Student Affairs, Mrs. Mutmainah MPD, our dedicated Language and Literature Club Supervisor, Mrs. Liana Prasilya SPD, the heads of Language and Literature Club, Aksi Redaction, and KIR, Banin Xiaomi, Kirani Anur Alodia, and Raisha Nisrina Hani. The head of the High School Scientific Conference Committee, Malfaquina, and our distinguished speaker, Ms. Jion Zaitel Nazal and Mr. Koshiro Saito, as well as our esteemed teachers, staff,
To begin our conference with blessing, let us take a moment to pray together. To ensure the smooth running today's event, the prayer will be led by Maulana Muhammad Farhan. The screen is yours.
Assalamualaikum warahmatullahi wabarakatuh. Before we begin this morning event, it will be beneficial for us to pray according to our respective religion and belief. Let us pray together that the High School Scientific Conference will run smoothly. Before that, allow me to lead the prayer according to my belief as a Muslim. Auzubillahiminasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin, hamdan na'imin, hamdan syakirin, hamdan yu'afi ni'amahu wa yukafi'u mazida. Ya Rabbana lakal hamdu wa lakal syukru kama yanbaghi li jalali wajhikal karim wa alim sultanik. Allahumma salli ala Sayyidina Muhammad wa ala ali Sayyidina Muhammad. Allahumma inna nas'aluka salamatan fid din wad dunya wal akhir wa afiyatan fil jasad wa ziyadatan fil ilm wa barakatan fil rizqi wa tawbatan qabla al maut wa rahmatan inda al maut wa maghfiratan ba'da al maut. Allahumma la sahla illa ma ja'altahu sahla wa anta taj'alul hazna idha syi'ta sahla. اللهم اغفر لنا ذنوبنا ولوالدينا ولمشايخنا ولمشايخنا والجميع المسلمين والمسلمات والمؤمنين والمؤمنات الأحياء منهم والأموات. ربنا هب لنا من أزواجنا وذريتنا قرة أعين واجعلنا من المتقين إماما. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. صلى الله على سيدنا محمد وعلى آله وصحبه وسلم بفضلك سبحان ربك رب العزة عما يصفون السلام على المرسلين والحمد لله رب العالمين آمين السلام عليكم ورحمة الله وبركاته
Amin ya robbal alamin.
صل-
Good morning, distinguished speakers, respected educator, esteemed guests, and my dear students. It's truly an honor and a great joy to welcome all of you to the High School Scientific Conference 2025, proudly hosted by SMAN 10 Bekasi. This conference is more than just an academic gathering. It's a meaningful platform where we come together to broaden our scientific understanding, exchange ideas, and connect young minds from different nations through the power of knowledge. As the headmaster of SMAN 10 Bekasi, I feel deeply grateful to have experts and educators with us today. Your presence and insight will not only enrich this event but also inspire our students to think more critically, act more responsibly, and dream without limits. On behalf of our school community, I would like to extend my heartfelt appreciation to our distinguished speakers, the organizing committee, and of course, all participants whose hard work and enthusiasm have made this event possible. With that, it's my privilege to officially declare this International Science Webinar open. May this event be a source of inspiration, learning, and lasting impact for us all. Thank you very much.
Thank you. Now, let us continue with the welcoming video from Mrs. Liana Prastilia, SPD, our LLC supervisor. Please give your attention once.
Is a chance for us to share ideas, learn new things, and good morning everyone. Welcome to the High School Scientific Conference 2025 at SMAN 10 Bekasi. We are very happy to see our speakers, teachers, guests, and students here today. This event is a chance for us to share ideas, learn new things, and connect with each other. We are grateful to have experts and educators who will guide and inspire us. On behalf of the school, I want to thank you guys speakers, the committee, and all participants who made this event possible. With that, I am proud to officially open the International Science Webinar 2025. I hope this event will be meaningful and inspiring to everyone. Thank you.
Thank you, Mrs. Liana Prastilia, SPD, for the warm and inspiring words. Now that we have set the tone for an exciting day ahead, let's take a quick breather before diving into our keynote session.
That's right. So help us loosen up and energize the room. We have a fun little session planned.
Please, will, please welcome our wonderful ice breaking.
So good morning, everyone. So my name is Chiquita, and today we're gonna do some ice breaking. In today's ice breaking, we're gonna do a game called Guess the Word. So let's get started. Okay, now the first word. What do you think this word is? Okay. Is anyone want to answer? What word is this? Okay, it's correct. The answer is milkshake. Okay, move on to the next one. What word is this? Great job. It's rainbow. It's rainbow. It's getting excited, isn't it? So we're gonna move on to the next one. What do you think this word called? What word is this? The movie?
3D
What word is this? Triple? Does anyone know the answer? Yes, great job. It's 3D movie. Okay, guys, great job. And we're gonna move on to the next one. What do you think its word is? Downtown? Is it correct? Is it correct, downtown? Yes, it is. It's downtown. Next one is, okay, I think this one it's kind of hard. It's kind of difficult. Okay, anyone know the answer? An overboard? Is that correct? Is that correct? Is that correct? Yes, it is. It's man overboard. Okay. Next one. What do you think is it? What word is it? Yes, guys, it's apple pie. Okay, move on to the next one. Is any? Okay, get it. For? What word is it? Yes, forget it. Okay, the next one. Okay, the next one. What is it? What word is it? Okay, the answer is pirate. The next one. What word is it? What word is it? Teacher. Yes, guys, correct. It's teacher. The next one. Okay, What word is it? Is that a cowboy? Is that correct? Is that correct? Is it? Is a cowboy. Let's move on to the next one. Is there any? Okay. Maybe that's all from me. Thank you guys for answering and listening. Bye-bye.
All right. Thank you so much, Chiquita, and thank you so much, everyone, for participating. That was definitely a great way to keep the energy flowing. Now that we're all warmed up, it's time to get inspired. With the welcoming session complete, it's time to launch into the heart of our conference. We're about to begin our keynote session. So prepare to be inspired, challenged, and informed by today's insightful presentations. Let's stay engaged and curious throughout. To our moderators, Livia and Michiko, we kindly invite you both to take the stage. All right, everyone, please give us a moment. So, Livia, you may now take over.
Right. Thank you, Lovely and Amar. Good day, everyone, and welcome. It's a pleasure to have you all in this timely and important webinar. Before we dive in, allow me to introduce myself. My name is Livia, and I'll be one of your moderators for today's event. This year's theme is Integrative Approaches to Future Technologies, the Nexus of Chemical Engineering and Artificial Intelligence in Shaping Sustainable Innovation. Sets the stage for a dynamic exchange of ideas across two interconnected disciplines. In our first session, we'll take a deep dive into sustainable innovation, chemical engineering, especially in its evolving relationship with data systems. Chemical engineering is no longer defined solely by lab experiments or plant operations. It's becoming increasingly data centric, integrating smart sensors, AI models, and real time analytics into everything from process control to emissions tracking. Today, we'll also explore the structure of chemical data supply chains, how information is collected, processed, and applied across the life cycle of modern chemical production systems. Before we proceed to the first part of today's discussion, let's take a moment to go through the keynote speaker CV. Today, we're with Ms. Jion Zaitel Nazal, a magna cum laude graduate of chemical engineering from the University of the Philippines, Diliman. Ms. Nazal has combined strong academics achievement with hands-on experience in both supply chain and research and development. Most recently, she works as a supply chain analyst at SG Johnson, Philippines, handling inventory analysis for over 200 products across the Asian region and managing product lifecycle transitions. Before that, she was an heir in the Internet Unilever Philippines, where she worked on packaging sustainability, testing, and supplier coordination. Beyond industry roles, she also served as project head for the UP Chemical Engineering Society, leading nationwide STEM outreach programs, workshops, and career seminars for more than 30 schools. Her technical skills span chemical process simulation, data analysis with MATLAB and Excel, and supply chain tools like SAP. She has also designed a planned project on converting plastic waste into energy-dense oil. With multiple awards, including being the champion of Unilever Business Week 2024 and the OST Merit Scholar, Ms. Nazel brings a strong mix of innovation, sustainability, and leadership to every role she takes on. Alright, we look forward to a deep dive into the mechanics of chemical engineering and the innovation. So, without further ado, let's begin the session.
All right. Thank you so much for that introduction, and good morning to everyone here in our webinar. Of course, I would also like to thank the organizers of this event. Thank you so much for inviting me to this wonderful event today. Okay, so today I will be introducing to all of you two engines of the modern world that make our lives possible. This is chemical engineering and the supply chain. Next slide, please. I would like to open my talk with a question. I think it's the previous slide. There we go. Thank you. So, where does your favorite ice cream come from? Maybe you could put your answers through the chat box. Maybe we could ask our moderators as well to read the answers in the chat box.
Okay.
So, where do you buy ice cream?
Oh, everyone
McDonald's,
say
yes. Mm-mm.
ice cream factory or supermarket.
Supermarket, yes, that is correct.
Mhm.
Walls ice cream.
Walls
That's
ice
actually where I
cream.
did my internship before. Okay. So before the ice cream gets to the supermarket, before the ice cream gets to McDonald's, before the ice cream gets to different other stores, where do these stores get the ice cream from?
Where, guys?
Where do you think that the ice cream stores get the ice cream from? Because of course, especially for ice cream like Walls ice cream, these stores don't make them themselves. Yes, that's correct.
From factory.
Yes, exactly. So the ice cream comes from the factory where it is processed. We have to go through a lot of different processes in order to make an ice cream, right? And then before we can create an ice cream in the factory, we of course need raw materials. So what kind of raw materials do we need in order to create ice cream? Yes?
Milk.
Milk. What else? Okay, I'm seeing sugar as well. Wow, you guys really love milk. Do you want to flavor the ice cream? What can we use to flavor the ice cream? We can use maybe fruits like strawberries.
Strawberry. Oh,
Yes,
yeah. Yes, strawberry is
exactly.
a good flavor for ice cream.
Is that your favorite flavor?
Yes, I love strawberry flavor on ice cream.
Great, great. Me too.
Yes. Oh,
So
yeah.
yes, I'm seeing here chocolate, vanilla. That's
Oh,
also correct. Okay.
matcha. Okay.
Yes, exactly. Okay, great, guys. So every product in our lives, from the laptop that you're using, the phone that you're using, all of our food, maybe personal care products like soaps and shampoos, and a lot more different products. Each product goes through the same long journey of having to be distributed, having to be produced, and having to source the raw materials that are necessary to create this product. Now, we traced this journey for the ice cream, and it's actually quite simple, right? Like, you guys already got it immediately. But it can actually get a lot more trickier when the product is more complex, meaning that the product would need a lot of different components and might require several steps in order to create the product. And it can get even more complex when this product has to be delivered to different parts of the globe, which is often the case for a lot of our products. Next slide, please. So behind the scenes of everything that we have in our homes are two engines, chemical engineering and supply chain. These are the two engines that make our modern lives possible. These are the very engines that turn innovations and products into our reality. So today we are going to dive into each of these two fields. Next slide, please. Okay, so what is chemical engineering? So chemical engineering is basically the discipline of designing equipment, systems, and processes in order to transform raw materials into useful products. So looking at the industries here below, can anybody give me an example of a raw material and the product that will be transformed for any of these industries?
So what does
So for example,
okay?
for pharmaceutics, for medicine, what is the raw material that we use and convert into what product?
Let's go, guys. It can be like herbal or from plants.
Yes, yes.
And etc. You guys can answer it in the chat box, guys. There's a lot of raw materials.
Does anybody want to guess?
Anybody want to guess? Any more raw materials?
Okay,
All
maybe
right.
they're still a little bit shy.
Yeah, it's okay, guys. Just answer it. Or we're going to move on to the next. Oh, crude.
There we
There's
have one
crude
example.
oil.
To
Crude
petroleum.
oil. Yeah.
That is correct. Crude oil is the raw material, and then petroleum is our product. Does anyone else want to guess?
Anyone else want to guess? There's a lot of raw material other than crude oil.
You can even give food as an example.
Food. Maybe you can tell the examples of the food.
Similar to what we did with the ice cream, where we said milk and fruits and other flavoring to create ice cream. But okay, all right. Thank you so
All right.
much for those who answered. Okay, so basically, what I want to show you guys is that anything that has to be
Can you hold this?
manufactured likely involves a chemical engineer. Chemical engineering is a very, very versatile field, meaning we have a lot of options to take up as a career in this field because there are many different industries that would need to produce many different things. Chemical engineers are often at the forefront of developing life-saving medicines and vaccines, creating more sustainable materials, and creating more powerful electronics and batteries, and many more. Next slide, please. So as a chemical engineer, you have to stand at the intersection of many different STEM fields. Unlike chemists, chemical engineers don't usually work inside laboratories. Instead, they typically work in manufacturing sites, or what we call plants, where they design the process. So what chemical engineers do is they scale up established chemical processes to enable a larger scale production. So could you imagine it from the fundal lab concepts that we have? The chemical engineers transform this into a big factory that is able to produce a lot of different products at once and be able to meet the needs of millions of people. But of course, we have to have the correct processes. So chemical engineers also are tasked to develop the right type of equipment. And in addition to that, because our processes often involve steps that require specific temperatures, pressures, and involve the handling of numerous chemicals, chemical engineers also have to be able to design safety components to ensure that the production is safe and to ensure that the system is always kept at the right conditions. At the end of all that, chemical engineers also have to design and monitor process controls in order to assess if the system that we designed is working as we want it to, and if we are achieving the desired reaction. Overall, chemical engineering combines math, science, and creativity in order to create a great product. Next slide, please. There we go. Okay, so once we have the product, how does it arrive to the consumer? Next slide, please. Okay, so this is where we go into supply chain. Supply chain is actually more closely related to industrial engineering because it focuses on creating efficient operations. In a nutshell, supply chain is about managing the movement of components, which are the raw materials and products, until we deliver them to the customer. The golden rule in supply chain is to deliver the right product in the right quantity at the right time. Does anybody want to answer why it is important for us to have the right product in the right quantity? Why do we need
Anyone
to
want to answer?
produce? Okay, sure. Go ahead. Go ahead.
Oh, so I think it's so important to have
Mm-hmm.
the right procedure because to create a better products, we have to be exact, smart, and then we have to be exactly being accurate about
Mm-mm.
the picking of the products and then of the materials, of course, and
Yes.
of course the procedure like from raw materials to distribution to consumer. It's also have to be seen.
Yes. Exactly. And then I also saw in the chat box somebody answered that it would be overproduction. That is correct. Um, Producing the right product at the right quantity is also very important because we do not want to overproduce. What happens if we overproduce? So, for example, if we're producing things with an expiration date, such as food, then if we overproduce and there is too much that people don't cannot consume all of it, what usually happens is that the food would go to waste, right? So that is not something that we want to happen. On the other side, if we underproduce, then that means that we are not meeting the demands and the needs of the people. On the other hand, why is it also important that we deliver the product at the right time?
Someone says to make sure the product is safe for consumption.
Yes, that is correct. That is correct. And then I'm also seeing that it might also expire. That is also correct. All right, you guys got it already. Okay, thank you so much for answering. Okay, so that is the golden rule of supply chain. So let's go through these steps one by one. Next slide, please. Okay, so the supply chain begins with sourcing the raw materials for what we want to produce. So when able to do this, you have to first understand what ingredients do we need and where are they available. Because sometimes not all ingredients are available in your locality.
Please.
Sometimes you would have to source these raw materials from another country or another city or another province, right? And then we also ask the question, where can we get these materials at the best quality and the best cost? And then now, because we are emphasizing on the sustainability of our processes, a lot of companies now are now asking, where can we get the more sustainable materials as well? So once we have the raw materials, we deliver these to the manufacturing plant. Here, at the manufacturing plant, we ask, can we manufacture enough products to meet the demand of the market? Because again, we do not want to underproduce, but we also do not want to overproduce. So to be able to achieve this, we have to coordinate with the manufacturing team to determine how much do we have to produce. Because again, we need to produce the correct quantity at the correct time. Next slide, please. And then once these products are produced, we have to bring it from the manufacturing plant to different stores nationwide and sometimes even worldwide. So what is the most cost-effective way to transport products? How can we deliver products in time? This becomes a trickier question when the products have to be delivered to farther distances. Sometimes you have to deliver to the other side of the world, and that could take several months before it arrives. This becomes more of a critical concern if the product has an expiration date, such as food products or personal care products. Eventually, the product will arrive at the shelves of different stores where customers can buy them. Next slide, please. So generally, supply chain deals with large volumes of data and numbers that we have to look at on a daily basis to allow the products to correctly flow from one place to another. As supply chain analysts, we depend on a forecasted demand that is based on historical data of sales and market trends so that we could know which product we have to produce and how much of it is required. So in order to do that, we have to predict the demand based on statistical tools. Recently, with the advancement of technology, other companies have also been leveraging machine learning technology to have more accurate predictions. On top of that, we also analyze data on the production so that we could spot immediately the inefficiencies in our process and improve this so that we could have a greater capacity to create more products on time. In addition to that, we also track different logistical processes, inventory, and shipments. And then, of course, we aim for continuous improvement in delivering our products. So for this, we continuously ask ourselves, is there a better way to source raw materials that might be closer to the manufacturing plant? Or we use different kinds of technology to check if there is a faster route that we could use in order to deliver faster. As a supply chain analyst, you have to be in the middle of everything. So you collaborate with the manufacturing team, material suppliers, and the sales and marketing team so that you could achieve the golden rule, which is again, to deliver the right product at the right time in the right quantity. Next slide, please. So all in all, supply chain ensures that products are delivered to the consumers, and that allows the product to have an impact. Because we can't really say that innovations have an impact already if the things that we create do not reach the people who can benefit from it. Next slide, please. Okay, so to summarize our two engines here, the chemical engineers create the product and then supply chain delivers it to you. Together, they keep the world that we know running. Next slide, please. But even if there are thousands of engineers and supply chain analysts who continuously develop these processes, there are still a number of challenges for both of these fields. So the number one challenge that we are facing right now is, of course, climate change. Because climate change can bring about very unpredictable calamities that can disrupt transportation and production. For example, in my country, the Philippines, we have had a lot of typhoons recently. And because of these typhoons, there has been a lot of flooding in our areas. And because we have a lot of flooding right now, it has become very difficult to deliver the goods to these areas that have been flooded, especially if these are in faraway provinces. So this is a real concern for everyone because that means that the people who live in those areas might find it difficult to get their basic needs, their basic necessities. And some people even have to travel to a different city or a different province just to get the things that they need every day. So because of the threat of climate change, we have to have stricter regulations in manufacturing plants. And that is where the work of chemical engineers come in. So now chemical engineers are focused on redesigning the processes so that we could have lower emissions and have a smaller carbon dioxide footprint. In addition to that, chemical engineers are also working to implement additional processes that would allow for better treatment of waste materials. Next slide, please. Can we go to the next slide? Oh, there we go. Thank you. So as you can see, there is still a lot that we can improve on in terms of optimizing energy use, making systems and materials more sustainable, and overall making processes more efficient. Next slide, please. But where do we find the solutions to these complex problems? So in the past few decades, we have been witnessing such a rapid development in technology. So as technology becomes more and more flexible and more accessible to us, it is simply undeniable that it will make a major impact and it will revolutionize the way that we do things. So we are now in what we call Industry 4.0, or the fourth industrial revolution, which focuses on using smart technology in our fields. So how does this apply to chemical engineering and to supply chain? Next slide, please. So the first example is the use of robotics and automation. In chemical engineering, we are already automating tasks that are repetitive and continuous to create more efficiency in our processes. And in the side of supply chain, for our warehouses where we store the goods before we distribute them, there are often robots or automated vehicles that help in unloading and loading shipping containers, or even help in moving and sorting products. Next slide, please. Another example here is the IoT, or the use of a lot of different sensors. So a while ago, we talked about how chemical engineers have to design controls to monitor different processes in the plant. So now with the development of technology, we now have more powerful and more sensitive sensors, which send in data in real time that allow us to prevent any accidents in the plant and optimize production as well. So for example, sensors can be used in order to detect chemical leaks immediately in the plant so that they could alert engineers in real time, who are able then to take action immediately and prevent any disasters from happening. Another example of this working is in supply chain when we have to deliver the products. Sometimes smart tags and sensors can be used to track shipments across oceans, trucks, and different warehouses. This helps us to track accurately the time that the goods would arrive, and it also helps us not to lose any goods during the process of transporting them. Next slide, please. And then lastly, the example is the use of AI and machine learning in these two fields. So as mentioned in chemical engineering, we can have sensors that collect real-time data and then transport that into AI software that can help predict and then adjust processes to maximize the yield and minimize the waste when we create products in our manufacturing plants. On the flip side, in supply chain, AI also can assist in forecasting and predicting demand, which in turn allows us to create just the right quantity of products. So all in all, this really helps us to reduce the waste that we have, and therefore helping overall our globe, right? Our world. Next slide, please. So with all of these developments, there truly is so much more to explore and experiment in both fields. And I personally think that it really is an exciting time for both of these fields as they continue to improve and develop with technology. Hopefully, hopefully this means that one day the products that we create will become more accessible to more people, especially the people who need it most. But of course, we have to remind ourselves that this integration of higher level technology is still quite new. So now we have to expect to encounter a whole new set of challenges that come with using these new technologies. So for example, how do we use these new technologies responsibly? How do we train our teams to use these new technologies? How do we educate them so that they could use these technologies? How do we balance the speed of automation with fairness? Or how do we balance efficiency with sustainability? So as we face these new problems, we would require even more innovative solutions. We have to make use of these innovative solutions to solve the problems that we are only now facing. So there are still really a multitude of problems that we have not solved yet, and that is where you come in. Next slide, please. So if you are interested in designing systems and solving problems, if you want to work directly on products that affect millions of people, then maybe fields like chemical engineering and supply chain are places where your skills can matter. So to wrap this all up, if there's anything that you will take away from this talk, It's that these industries, chemical engineering and supply chain, aren't just about creating better products, they are also about creating a better world. And there will always be space and a lot of opportunities for young and brilliant minds like you to get involved and to begin
So
engineering
there
our
are still
tomorrow
really a
today.
multitude of problems that we have not solved yet.
All
And
right.
that is where you come in.
Thank you.
Next slide, please. So if you are in
Alright, I think there's been a mistake. It's okay. You may continue, miss. It's okay.
Yeah, that's the end of my talk. Thank you so much
Oh,
for participating and for listening.
thank you so much. Alright, thank you so much for Miss Nazel for the presentation. In here, we can study more about supply chains and chemical engineering, where it combines together and how it works. So now we're moving into a short interactive game to refresh and reflect on what we've just learned. So our committee will show you the QR code of the game, so you guys can scan, and we're going to start the game. Let's go, guys. You can scan the barcode. If you guys already scanned the QR code, you can tell me on the chat box. It's okay? Someone already scanned the code? Okay, so the time for scanning the barcode is only 3 minutes, so you guys can hurry up and scan the barcode. Come on, guys. Let me know if you guys already scanned it, okay? You can scan it? Uh, try again, try again, try again. You can? Okay. Thank you, guys. Alright. What's the game ID? Can you just scan the code? Let me know if you guys struggle with scanning the code. Oh, okay. For you guys that asking for the ID will shown by our committee in the screen, on the chat box, so it's okay. Alright, thank you so much, guys, who scanned the code. Come on, guys. Let's see how many people have scanned the barcode. Alright. If you guys have a struggle scanning the barcode, there's an ID on top of the screen. You guys can input it. The game is named Blockhead, guys. Oh, there's 6. The ID is on top of the screen. Let's go, guys. The merrier, the better. Thank you so much for telling the ID. The ID is on top of the screen, guys. If you guys any more struggle, just tell on the chat box, okay? It says it's full. Oh, it says it's full. If you guys can join, it's okay. You guys can still see how the game play. So stay in this and keep interactive on the chat box, okay? So everyone ready? It's okay. It's okay if it's full. You guys can still look the gameplay. Yeah. Okay. If you guys struggle to join, you can answer on the chat box or on the YouTube comment. It's okay, guys. You can always answer it on the chat box because our committee will see your answers. All right, everyone ready? Then, okay. If everyone ready, okay, let's play the game now. Let's start the game. Get ready. A new technology widely used in the chemical process industry is. Come on, guys. Wow, you guys are speeding up. 2, 1. The answer is AI and automation. Automation systems. All right, next question. Wow, Adriel. Adriel, great job. Let's go on to the next question. Ooh, what's the answer, guys? Integration of chemical engineering with other STEM fields involves. Come on, come on, come on. The time is running. All right, what's the answer? The answer is information technology and data. Good job, everyone. Ooh, Nadira, you take over. That's good. Good job, Nadira. Next question. Who is the speaker presenting this material? Heyo, who is it? Who is it, ya? You guys, of course, know, dong. Jian Zeto. Oh, there's people answering. Yeah, great job, everyone. Okay. Nadira, good job. You're keeping up. That's good. Next question. One of the challenges in the digitalization of the chemical industry is. What is it, guys? Oh my god, you guys are so speeding up. Lack of widespread technology adoption. Good job, everyone. Come on, guys. Don't give up. What are the benefits of using digital systems in monitoring chemical processes? What's the answer, yeah? The green one? Are you sure? Oh, that's correct. Great job, everyone. Oh my god, everyone answers correct. You guys are listening to the presentation, yeah? That's great. Digital sensors in chemical plants are used to? Come on, what's the function of digital sensors, guys? The red one. Everyone says the red one. Is it the red one? Yes, it is. Great job. Oh my god. What's the answer? Come on the chat box. Green? The answer is green. Oh, Nadira. Eighth question is Ooh, good job. Everyone just answered the right question and you guys are great. You guys are great. Okay, next question. What does digitalization mean in the context of the chemical industry? Let's go. Yellow. Using digital technology to improve processes and efficiency. Is it correct? Is it? It is. Yay! The last question. Let's go, everyone. What is the role of data analytics? The answer is green, providing data-driven insights for decision making. All right, everyone. Ooh, we've got our ranks here. Good job, Nadira, for winning first place. Yay! Good job, Kendra and Azril too. It's okay. All right, good job, everyone. Thank you so much for participating and for your enthusiasm throughout the session. It's always exciting to see how engaged you all are. And now I'll pass the screen over to my partner, Nichiko, who will guide us through the next part of today's program.
Thank you. Thank you so much, Livia. Thank you so much, Livia. Hello again, everyone. I'm Nichiko. I'll be moderating our second session where we'll shift gears from mechanical engineer to the world of artificial intelligence, focusing specifically on large language models or LLMs. These models represent one of the most advanced forms of AI to date, capable of performing tasks traditionally associated with human intelligence, such as reasoning, language understanding, and complex decision making. From the transformer architecture and token embeddings to attention mechanisms and fine tuning, we'll explore how these systems are built, how they work, and how they're reshaping the way we interact with technology. But before we begin our discussion, it's an honor to introduce someone whose work has greatly contributed to this evolving field. Let us now take a moment to hear the profile of our distinguished keynote speaker. Today, we are joined by Mr. Koshiro Saito, a master's student at the Institute of Science Tokyo, specializing in natural language processing and large language models. His research focuses on artificial text detection and Japanese experience through a research internship at Cancer Scanning, working on healthcare AI, as well as his role as a research assistant, developing and evaluating LLMs. Mr. Koshiro has, has also received recognition for his work, including the Excellence Award from YANS and the Research Excellence Award from IPSG. Beyond research, he is skilled in Python, OpenAI, and API, and has strong English proficiency. Please welcome Mr. Koshiro Saito.
Hello, selamat pagi. Is it correct? Can you hear me? Thank you for introducing me.
Yes.
Okay, thank you for introducing me. I'm Koshiro Saito, a master student at Okazaki Laboratory in the Institute of Science Tokyo in Japan. I'm majoring in AI or artificial intelligence and specifically LLM or large language model. And LLM is a sort of AI which can understand natural language. And probably some of you have never heard of natural language before. It is what language we use every day, like Indonesian language, Japanese language, and English as well. So natural languages are considered distinct from artificial languages, such as programming languages and mathematical symbols. So in short, I'm a master student from Japan, majoring in AI speaking in natural languages. Okay. So before moving on to the main topic, I'd like to appreciate all of the staff, especially those who communicate with me and created these wonderful slides for me, and Okta Sensei. Okta Sensei is the person who gave me this special opportunity, actually. And Okta Sensei and I have known each other for several years, and I first met in an exchange program in Thailand. I guess it was 2 or 3 years ago. And most impressively, I remember one night where Okta Sensei, my roommate, and I were talking about each mother country's culture. And then he was already eager to be a teacher, good teacher, considering students first. Is he so? I hope so. And so when I received the invitation from him, I was so amazed, but at the same time, it made sense in a second. Again, thank you to all of the staff, teachers, and participants. For the last thing, English is my second language, so I may make some mistakes or make you feel uncomfortable or confused. So I'd appreciate it if you would be generous or kind to me. Thank you in advance. I hope you relax, enjoy, and find something interesting you. Oh, thank you. I just wanted to say that. Today's topic is AI, LLMs, and watermarking. The earlier part will deal with the basics of AI and LLM, and the latter part will deal with my research topic, watermark. And both section will go in a Q&A style, where I will go through the slides by answering the questions I received by the staff in advance. And some of them may be overlapped or too complicated, so I will skip or simplify those contents. Okay, firstly, let's check the basics of AI and LLMs. As shown now, the first topic is, what is the difference between AI, machine learning, and deep learning? Next, please. Thank you. So before I explain, I'd like to know how many of you have heard of these terms before. If you don't mind, please raise your hand after I ask you. Have you ever heard of the term AI?
Does anyone raise your hands or answer in the chat box?
Yes. And then machine learning.
Does anyone know or heard of
Oh,
it?
yes. And
Wow.
And lastly, deep learning. Oh, some people say yes. Oh, yes.
Yeah.
Okay, then finally, have you ever tried to do machine learning or deep learning by yourself?
No, I personally never,
Oh,
but maybe the
yes.
participants have. Oh, not
Some
yet.
people said
Oh,
yes.
someone did. Oh, wow.
I'm so amazed. Oh, thank you, everyone. Thank you. I get motivated. Okay, then let me explain one by one. For short answer, AI is a broad concept. And one method for achieving AI is machine learning. And within machine learning, one method is deep learning. And today, there is a tendency for anything to be called AI. And actually, strictly tracing its origin, there is no clear definition of term AI itself. However, according to Professor John McCarthy, known as the father of AI is the science and engineering of making intelligent machines, especially intelligent computer programs. And obviously, the term AI itself is an abstract concept, so anything that behaves intelligently like a human is AI. And for achieving AI, the researcher had to make every single rule and every single pattern by themselves. I mean, they had to program everything. However, thanks to machine learning and deep learning, AI can learn by themselves by learning large amount of data. Okay, next, please. Thank you. The second topic is, how does AI work and what components makes it up? Generally, AI predicts on new data based on patterns and rules gained from large amounts of data, so-called training data. So while there is no general definition, but I personally believe that there are three components: data, learning, and prediction. And data should be a large amount of data aligned with the final use case. And if it contains exceptional values, they must be appropriately removed or pre-processed before. And for learning part, there are many algorithms, and their accuracy, computational cost, and suitable use case differ so much. So this must be decided considering the final use case and also the available resources as well. And for prediction, the computational cost is generally lower than learning. However, using large models like ChatGPT requires a large amount of high-performance hardwares like GPUs and a large amount of energy. I mean electricity. Okay, so AI cannot exist if any of them components are missing. So next, please. Okay, thank you. The next topic is how AI used to process and understand human language. It's a little bit complicated, but traditionally, AI, not only LLM, has been used in natural language processing for mainly 4 purposes. First one is morphological analysis. It's to divide a sentence into its smallest meaningful units like words and identifying the part of speech of each. And the second one is syntactic analysis. It's to analyze the relationship between words to clarify the sentence structure, like subject and the predicate, or predicate and object. And the third one is semantic analysis, and it's to understand the meaning of a sentence, like whether the sentence is negative one or positive one, whether the relationship between two sentences is entanglement, contradiction, or neutral. And the last purpose is contextual understanding. It's to analyze relationship across long texts or multiple sentences to understand the overall theme or overall intent, such as reading comprehension questions for long text, or question answering for a document. For these purposes, AI has been used in natural language processing before LLM. Yeah, AI has greatly improved my productivity and same. Yeah, me too. And I think I rely on AI too much. Okay.
Same. I do sometimes, Yeah, when doing homework, sometimes I use AI too.
Yeah,
it's
me too.
very important too sometimes.
Yeah, me too. I cannot live without
Can
AI.
can I ask some questions?
Oh, okay.
Is it okay? Right. So, why does contextual understanding is important for AI?
Oh, contextual understanding. Because let me see. So when you use ChatGPT or some other LLMs, I think you input some text or instruction, right?
Right.
And I think in some case you input several times. Please do something, and then. So for that case, AI have to understand the long text or multiple sentences to understand the context, right? So if the AI can understand only single text, it cannot help our needs, our needs. So AI has to understand the contextual meaning. Does it make sense?
Thank you. I understand. Yes. Thank you so much. You can continue your presentation.
Oh, thank you. That was a nice question.
Thank you.
Okay, the next slide, please. So the next topic is, why is language understanding a major challenge in AI development? And some of you may know that in fields such as image classification, image recognition, or the game of Go, AI systems surpassing human had already been developed, I think, several years ago. However, it was only quite recently that LLMs emerged. So why is that the case? I personally believe that the reason includes some points, but due to the limited point, I want to share the important one. Let me see. Okay, so the first one, I think the most important one, is ambiguity of meaning. Even a single word or expression can convey different meanings or nuances depending on the context or speaker. Moreover, cultures and even individuals have different values about everything. For example, like what is correct or incorrect, what is good or bad, what is preferred or disliked. So it is so difficult for AI to master the nuances perfectly because AI just outputs the words through mathematical, mechanical, and statistical calculation, not considering emotion or anything else. And the another point I think it's the most important and recently get more important is lack of embodiment. For the time being, AI does not have a body, at least so far. So this means that AI cannot grasp the physical sensations that we human implicitly assume. For example, in human communication, in human conversation, even with the same text, same tone, the nuance can be completely different if hands or eyes movement different. So it must be different for AI to grasp such unspoken meanings. Okay. Do you have some questions so far?
You can continue your presentation.
Okay. So the next slide, please. Yeah. Thank you. I see many of you are interested and I see the chat now. I'm so happy. And the next topic is, can AI answer questions without using LLMs? And the answer is yes. And to recap, AI is a broad concept and LLM is just one of them. So AI technologies other than LLMs can also be used to answer questions. And more precisely, even before LLMs became so widespread, various AI technologies have been used to address the task of answering questions. Our LLMs is large language model, AI speaking in natural language. And there are several points, but I want to explain two of them. The first one is rule-based system. It was the most intuitive and old implementation. It is a method where humans strictly program rules in advance, and their system answer given question based on those rules. It's most old one. And the second one is expert system. An expert system is system composed of a knowledge base and the inference engine. And the knowledge base stores a vast specialized inference engine infers based on predefined rules. And the humans needs to define large amounts of data in knowledge base using rules like if-then format. If the question is A, the answer is B, or something like that. So it was tough, I think. So next slide, please. Thank you. And the next topic is, what is a large language model and how does it work? As the name suggests, a large language model is a model that learns a large size of languages. And more precisely, it is a model with a very large neural network trained using an enormous amount of text data. Oh, does somebody have a question or some trouble?
No, I think someone just asked what is LLMs and the other just answer it. They're very engaged in this.
I saw some
very
raise the
happy.
hand action.
Oh.
Yeah, but
Really?
it's gone. So
oh yeah.
I will continue.
Don't worry about them. Yes.
Thank you. And so the basic mechanism of LLM is to repeatedly predict the most likely next word from a given sentence. And to learn what is most likely to come next, it needs a vast amount of text data. To learn things like this word comes after this word, or this expression comes after this expression. For example, Tom often comes after I am, or an answer comes after a question, something like that. So next slide, please. Thank you. So why do LLMs require large amounts of data to understand and generate languages? As I said many times in this presentation, LLMs require large amounts of data. And because the AI have to learn what is natural as a sentence. And this naturalness varies depending on the context, domain, culture, language, and even individuals. So diverse and enormous data is required according to the final use case. Next, please. Can we go to the next slide? Thank you. The next topic is what are the advantages and disadvantages of LLMs? And there are many pros and cons, but here I'm going to share with you the main ones. The most biggest advantage of LLM, I think, is LLM can produce responses that sound really human-like and really fluent. I think it's the most advantageous. And the second most advantage is the LLM can reason recently. I mean, LLM has become capable of handling advanced reasoning tasks like mathematical, physics, and even programming. And it's a very recent point. And for disadvantages, something like the detailed reasoning process leading to the final answer. I mean, how LLM can answer question correctly, the mechanism is not fully understood yet. And it's called a black box problem. And the second one is, although the answer look like human-like, I mean fluent, but the content may be incorrect. And it's called hallucination or just biased. And this could have a negative impact on users, especially, I think, for young users. And the third point is training data is collected mainly from the internet, so copyrighted material and personal information may be included in the LLM's answer, and it's called data leakage. And these are the main things. Next slide, please. So I think here, from here, the topic is going to be a little bit complex and difficult. And the topic is, what role do transformers play in building the capability of today's LLMs? I guess less people have heard of transformer compared to AI, machine learning, deep learning. However, transformer is a core architecture of LLM. And a transformer is an architecture for LLM that helps them understand the text according to the context. Before the advent of transformers, popular architecture like RNN, recursive neural network, it had a problem that was forgetting initial information as a sentence became longer. And in contrast, the self-attention mechanism of a transformer makes it possible to efficiently capture long-range dependencies between words. And actually, the T in ChatGPT stands for transformer. And most LLMs, such as Google's Gemini and Meta's Llama, adapt this transformer architecture. Okay, next slide, please. And the next topic is more technically. And what is the basic structure of transformer and how do they differ from the previous models? And the basic structure of transformer is mainly divided in two parts, encoder and decoder. An encoder is the part that reads the input text and converts the meaning of each word and its contextual importance of each word into numerous information. We call them vectors. And the decoder, it's the part, receive the numeral information, vectors, and predicts the next word to be output. So the significant difference between these transformer architecture and the previous model, besides their advanced contextual understanding, is that they can compute parallelism, parallelly. While previous mechanism like RNN, recursive neural network, calculated the words sequentially, I am Tom, and something like that. However, transformers calculate all words in a sentence at one time. So this enables parallel computation using GPUs, and it leads to faster learning and faster prediction. Next, please. Thank you. Oh, the slide is moving. I didn't know that. The next topic is, how does self-attention work in transformers? As I said before, transformer is a core architecture of LLM, and the self-attention is a core architecture of transformer. And a self-attention is a mechanism that calculates which word in a sentence should pay attention to which word in the same sentence. So for example, let's consider the sentence like, I bought an apple and ate it. In this case, what word does this it represent? And the self-attention calculate the relevance of each word and allowing it to understand that this it represents an apple. And this is the role of self-attention. Pay attention to text themselves. Next slide, please. Thank you. The next topic is, what are the advantages and disadvantages of a transformer? For advantages, as I mentioned before, it can parallel processing or can capture long-range dependencies. However, it has also disadvantages, right? Like it requires high computational cost and a high computational memory. And the order is n squared, where n is the input length. So when the input length is double, the cost is 4 times larger. And a transformer, sorry. So this is the last slide dealing with the basic of LLM and AI. So from here, I'd like to talk about my research topic, watermark. Next slide, please. Thank you. Watermark is interesting, I guess. And the next topic is what is meant by the watermarking and what is its function. In this field of LLMs, watermarking is a technique that enables us to detect which text is made by LLM. Okay, let me explain in more detail. Next slide, please. So how does watermark work? For example, if Koshiro LLM is adjusted to use more John than Tom, more football than soccer, more night than morning, then a sentence like John played football last night can be inferred to have been generated by Koshiro LLM, right? But on the other hand, Tom played soccer last morning can be inferred to have been generated by other LLMs. Though this is just a toy example, but what implemented this at the high level is the most common implementation of watermarking. Next, please. So why is the watermarking becoming important in the era of large language models? So as LLMs become more high-performing, their output becomes indistinguishable from human written text. So this could lead to some problems. For example, first, document falsification. It's what it's what we talked before. I think that the top of this presentation. For example, students using LLMs to write reports for assignment could submit reports that do not accurately reflect their own opinions or their own learning progress. And the second point is lack of accountability. When a certain text causes ethical problems or legal problems, now it would be impossible to pursue the accountability because it is unknown who or which LLM generated the text. So to solve these problems, watermark is necessary. Next slide, please. Thank you. I guess it'll be the last slide. And this topic is, what are the main challenges in creating AI watermarks that are not easily removed or manipulated? Developing watermarks themselves presents many challenges, but creating ones that not easily removed or manipulated require even more challenges. First one is maintaining quality. So manipulating the text generation process to input a watermark will inevitably lead to text quality degradation problem. For example, in the previous toy example, John played football last night. The manipulated model might output John football and night. Even in a case, Tom soccer morning would be more natural and preferred. So maintaining the original quality while still having a watermark is one challenge. And the next point is ensuring robustness. For shortly, user edit LLM's output. So we have to detect every part of LLM generated and every part of human written. So it's so difficult. Okay, next slide, please. Thank you. Actually, I have another topic, but due to the time limited, I will skip. So that's all for the topics I wanted to share with you today. In everything we do every day, like such as communicating with each other, operating devices, or keeping records, we use languages. And the large language models are the first AI technology capable of handling human language with high level. So I believe that LLMs will become deeply integrated into our lives, and not only in the digital domain, but beyond. So if today's talk has sparked even a little curiosity in you, now is the perfect time to get started. Thank you very much for your attention.
Okay. Thank you so much, Mr. Koshiro, for that wonderful presentation. There's so many we can learn from what you've just explained to us. Now, before moving to the Q&A sessions, we'd like to invite you guys for another game. And I hope you guys still remember the material. So, let's see how you guys will do on the second game. Please scan the QR. So, for the people who played the game earlier, you can join now. So you can play the game because you didn't play, right? I give you guys 3 minutes to scan the QR code. If you guys can scan it, we'll show the ID to the screen later after 3 minutes. guys, have you guys scanned it? Please tell in the text box. Oh, wait for the ID. Okay. Okay. Okay, there's the ID on the screen. 1582688. Okay, there's people joining. Come on, guys. Ooh, so fast. You can't, if you haven't scanned, just put the ID. One more person left? Wow. ID, please, there's on the screen. Do you want me to spell it out for you? 1582688. Have all you guys joined the game? Oh, it says false. Oh no. You can just answer in the textbook letter. Is it okay for you guys? Okay, should we just play? And okay, let's play the game. You guys ready yet? Okay, it's already. The abbreviation of for AI is 9, 8, 7, 6, 5, 4, 3, 2, 1. And the correct answer is artificial intelligence. Congratulations for the 37 people who answered that. Wow. Next questions. What is the main role of the transformer architecture in LLMs? I think I already know the answer. Come on, guys. 2, 1. Ooh. Wow. Congrats to the 28 people who answered red. And Dido is taking the lead. Congrats, Dido. Keep up. Next questions. What is the advantage of self-attention in transformers? Someone said yellow. Is it correct, yellow? Green and yellow. Oh, green. It's all right, guys. Next questions. What AI application is used as a virtual assistant? I think everybody knows this answer. 3, 2, 1. Everybody said yellow. Is it correct, yellow? It is correct, yellow. Congrats. And Dido is still taking the lead. Wow, impressive. Next question. What is the abbreviation for LLM? Oh, I think everybody knows this answer. It's easy. Is it yellow? Yes, it's correct. It's yellow. It's large language model. And Dido is still taking the lead. Wow. Next questions. What is the name of the architecture used in many modern LLMs? It's easy. Come on, guys. It's yellow transformer. Next questions. The website crashed. Maybe it's your connection. You can just rejoin or comment in the text box. What is the main purpose of watermarking? Everybody said yellow. But is it correct though? It is. Wow. You guys are smart. And now Tafia is on the lead. Congrats, Tafia. Wow. Next questions. Two more questions left. What are some examples of AI applications that use LLM? I think this one's so easy. I think you guys all know. Green. Is it green? Answered Google Maps. It's all right. It's all right, guys. But the correct answer is ChatGPT, the green one. Wow, I don't see Dido here. Where's Dido? Okay, still Tafia is on the lead. Great job, Tafia. And two more questions. What are the benefits of using AI in business? Ooh, people said blue. Is it blue? Yes, it's blue. Correct. Nice job. Next question, or the last question. Why is language understanding challenging for AI? Is it yellow? Is it blue? It's red. Is it red? Ooh, someone said blue or yellow. Oh, the correct is red. Yay! And for the winner is Tavia. Congrats, Tavia. You did so well. Wow, you guys are all so awesome. Still excited and competing very well. Now, we're moving to our Q&A sessions, where we'd love to hear from all of you. Since this is an online event, feel free to drop your questions in the Zoom chat or use the Q&A feature, whichever is more convenient.
Alright, guys, for you guys who wants to ask questions, you guys can drop your questions on the YouTube live chat or on the chat box, whichever more convenient, and we'll answer it.
And for you guys who wants to ask, say it in the text box, but say who you want to ask it for. So we have to point it out, like maybe for Mr. Koshiro or Miss Nazal. So yeah, wait for a moment. So we have a question here to Mr. Koshiro from Nicholas. He said, I want to ask, what is LLMs and what it's used for? For Mr. Koshiro, you can answer the question.
Okay, thank you for your question. And an LLM is a large language model, and it's a kind of AI speaking and understanding natural language. And the natural language is what language we speak, like Japanese, English, Indonesian language as well. So LLM, for example, can answer your question or can write text or can generate a story, or recently can even speak with you for your practice of English speaking, something like that. Does it make sense to you?
Does it make sense to you, Nicholas? If it makes sense, I'll continue to the next question. Please answer in the text box.
Alright, next question. It's for Miss Nazal in the comment section from Philip. So he asks how we can distribute the goods of our products more effectively and with low distributing costs. Miss Nazal, you may answer.
Okay, so there are a lot of different ways on how we can distribute the goods efficiently and at a lower cost. So, for example, one of the things that we make sure of when we transport our products is, for example, we are given a container and then they give us the volume of the container. So, from the volume of the container, we can compute how many of our products can we fit in there in order to optimize the space that the container has. Because what we want to do is we want to optimize the use of the space of the container so that the cost of the transportation per product can become lower. So that's one of the things that we do. Another thing that we do, of course, is we have to time our transportation logistics with, for example, the fluctuating prices of gas, because that is primarily what our transport systems use. So sometimes we have to time that together with the fluctuation of gas prices so that we could get the best cost that we can. So yes, those are the two examples that we commonly use so that we could transport more effectively.
Right. Thank you, Miss Nazal, for the answer.
Thank you.
Next question. Pilih.
So when Mr. Koshiro did the presentation, someone already asked in the comment section on YouTube. So, but the question is for Mr. Koshiro and Miss Nazal. So both of you guys. So, the question is, what are the risks of continuing to push young people to change the world without providing them with structure, guidance, and protection from mental, social, and political pressures? Thank you. And that question is from Rio Sanjaya.
Um,
And you can answer first.
It's
Thank
a
you.
question for me, right? And sorry,
For,
I missed
I'm sorry for both Ms. Nazal
both
and
of
Mr.
us.
Koshiro.
Okay. I missed
Yeah, for both.
I missed the core contents of the question. Sorry. Could
Do
you
you want me to repeat?
Yeah, could you repeat or say the
Yes. Okay. What are the risks of continuing to push young people to change the world without providing them with structure, guidance, and protection from mental, social, and political pressures?
So
Okay.
is it correct that my understanding is that what is the risk if we continue and use AI or LLM more to change the social system?
Without
Or is it
providing,
like in general?
In general?
maybe based on what you did for the presentation. Maybe if Mr. Koshiro,
Okay.
you can change it into pushing young people to use AI, or Ms. Nazal pushing, maybe like that. It's like two.
Sorry, the connection is not so good, but I catch the what is the risk of using AI continually, right?
Yes, without providing them with structure, guidance, and protection from mental, social, and political pressure.
Without appropriate protection.
Yes.
I totally understand that. And the question is so important. And actually, for LLM field, many companies many companies are very eager to make their LLMs more high performance, more cheap, something like that. But it's the first priority for them. The safety or the mechanism why LLM can answer question is the third or fourth or other priorities. So I think the situation so far is not so good. So we have to secure the mechanism of LLM first. And so, yeah, as you're concerned, I think if we continue to use LLM or AI as we do now, there'll be some big problems soon.
Thank you for answering, Mr. Koshiro. Okay, I'm sorry, Ms. Nazal. You can continue to answer.
Sorry, can I clarify? The pressures are
Oh, the pressure
that it was mentioned in the question?
Oh, without providing them with structure, guidance, and protection from mental, social, and political pressure.
Oh, okay, I see.
Yes.
Okay. Yeah, so of course when we speak to students, of course we inspire them to take up the fields that we are in. or really any field in science, technology, engineering, and mathematics, right? But ultimately, I would advise students to really um, seek the advice or guidance from your teachers or from other professionals in the field that would really help you and guide you through your career, because that's really the best that you could do for yourself to guide yourself from, I mean, to prevent the pressures from social pressures and other type of pressure that you may experience as a developing young professional. Um, in terms of political pressure, I do, you have to understand that a lot of these industries, they don't exist on their own. So these industries are, of course, affected by the political environment in your country or even the political environment globally. It has a very real effect to all of the industries that we have right now. And so if there is like some pressure or some trouble politically that you may be experiencing where you live, it really goes down to advocating for what you think is correct, so that, so that our political leaders would be more inclined to listen to us and to actually provide us with good solutions and guidance so that we could achieve what we want to achieve as a nation. So it's really, it's a big problem, but yeah, you have to understand that as you pursue any career in STEM, it's not, we don't live alone. Um, we have to keep working with other people and other professionals from different fields outside of science and technology as well. Yep.
Thanks a lot, Ms. Nazal and Mr. Koshiro for the answer. So let's move on to the next question.
All right, the next question is also for Miss Nazal. And so it's from Azrael. As you've explained very clearly before, AI and the development of technology are helping significantly in supply chains and similar fields. So, in your opinion, how would you propose the continuity of human labor in the midst of these circumstances? Because as per today, they think very many people is still dependent in their jobs at the supply chains and chemical engineering fields. For Ms. Nazal, you may answer.
Okay. I don't know if maybe Koshiro shares the same opinion as I do, but I believe that because we're the people are the ones who make these AI systems, these different technology. So I personally believe that whatever happens, people will always be ahead of AI, will always be ahead of any type of technology, because it is from us, it is from our brains that this technology comes from. In my opinion, how do I propose to continue human labor? I feel like human labor would always be necessary in whatever industry, because we always have to be there to be able to monitor, as I mentioned, to monitor and to operate these technologies. Otherwise, it wouldn't work perfectly. Like, for example, in my field, I have to analyze data on a daily basis. We use a software to be able to process these data more efficiently and more easily. But even if we have this kind of software, it is not perfect. And so it requires human intervention. It requires human labor still, so that we could correct the lapses, the mistakes that these computers still make, right? And then on top of that, I think in terms of human labor, of course, what computers and technology can do is only limited to what we program them to do. But other sensitivities that may be outside of their programming, they aren't that skilled to detect those yet. So on our end, like, it's our job as people in these industries to be able to fill in the gaps of the technology that we have right now. So I think, yeah, all in all, people are still very important. I don't think we should be scared that technology will overcome the people in the industries.
That's right, that's right. All right. Thank you so much, Ms. Nazal, for answering the question. We're going to move on for the next question.
Okay. The next question is for Mr. Koshiro. Here in live chat YouTube comments from Dido. Could an LLM ever develop moral wisdom, not just follow?
Sorry, the connection was.
Oh yeah, I'm sorry.
Or
I will repeat.
could you type the chat? Could you type the question in chat again?
Do you want me to repeat or just text on the text box?
Yeah, chat box, text
Chat.
box.
Okay. Okay, wait.
Thank you so
There,
much.
I've written. Okay.
Thank you so much. I'm not so good at listening to English, and my connection is not so good. So could an LLM ever develop moral wisdom, not just follow rules, but understand the moral ways of its choice? LLM could develop moral. Oh, it's a deep question, I guess. And certainly, I think as you may feel, LLM can answer correctly to some mathematical questions or physical questions or programming as well. But it's a problem that they don't have emotion in it as we do. So they don't master what is moral and what is against to moral, or what is good, what is comfortable, what is healthy, something like that. And certainly, we researchers and developers train LLM on data, and then the data is about moral or how human feel. So we really do that kind of train, but I guess it's not so perfect. So sometimes LLM say something too bad, and something humans don't say in that way. So yeah, I think your concerns is so important, and LLM cannot catch moral wisdom so far. Thank you.
Thank you a lot for the answer, Mr. Koshiro. So let's move on to the next question.
All right. The next question is for both Mr. Koshiro and Miss Nazal. It's from Andrew. And the question is, I want to ask about, do AI and robots have an equality? You may answer.
What do we mean by if they have an equality? Can we clarify?
It's from Andrew. I think that they mean is what's the same, I mean the similarity between AI and robots, and do they have any connection or any difference between AI and robots?
Mm, I think Koshiro could start on this one. Would you like to start on this one?
Okay, thank you for your kindness. And in my field, when we consider about equality, we were talking about the contents of LLM's output, whether it is biased or not, whether it is biased or not. And so, for example, probably LLM made in one country often output something good for the country and bad for other country. It can be happen. And for other use cases, like if company, it's a future story though, if companies start to use LLM as a job hunting interview or something like that, maybe the LLM output a higher score, higher grade on some people in some country. It can be happen. So I guess the current LLM doesn't secure equality in that sense so far.
Yeah, I agree with what was mentioned. Yeah, so as explained by Koshiro, um, equality isn't yet the best with the current technology that we have right now. And so that is why we come back to the point that I made earlier that at this point, human intervention is still really important as we continue to develop the technologies we have, because we are the ones who safeguard technologies from creating bias. So we are the ones who have to protect the equality in what the technology does.
All right, thank you so much for the answer from Mr. Koshiro and Mrs. Nazal. We're going to move on to the next question.
And the question is for Mr. Koshiro here from the text box. Someone just said that he would like a better explanation about transformers. Self-attention mechanism for transformers. Can you explain more about it or re-explain? Thank you.
Thank you. Thank you for that question, and I thank you for having very strong interest in the core architecture. Actually, it's a little bit too complicated to explain here, but if I'm allowed to share the YouTube URL, I can share with you the material you can study. Can I share the URLs on text box? Of course, thank you. So I have two suggestions, recommendation, and all of these uploaded by a single channel. And as some of you know, in Japan there is a Tokyo University of Tokyo, the most top university in Japan, and the Tokyo University upload the translated version of the video clip. So I think the quality and the content is secured. If it helped you, I'm so glad. Thank you.
Okay, and let's move on to the next questions.
All right, this is for Ms. Nazal. I want to ask, so cybersecurity and data privacy were mentioned, and so because ethical issues in supply chains management. You may answer that.
Hi, could you type the question again to the chat box? I think the connection was, yeah, the connection was a little bit shaky.
Oh yeah, okay, all right. Yeah, the connection is so poor. I'm sorry.
It's all right. No worries, no worries.
Alright, I've sent it.
Okay. So, cybersecurity and data privacy, and why are they critical issues in supply chain management? Okay, so from my experience, the software that we use, so for each of the product of the company, in the software that we use, we also store there the list and the amount of raw materials that is needed to produce one unit of each product. So basically, in our software system, you can already have access to basically all of the ingredients that is needed to create our products. And basically, you're sort of finding, you can imagine it as sort of like finding the secret recipe to the products of the company, right? Which is, of course, this is the intellectual property of the company. So it's something that should not be publicly available or publicly shared. So for our case, what we do is that we have a team that generally they regularly check the security of our systems to make sure that it is safe, that we are not leaking any sort of data. But at the same time, with the manufacturing teams that we work with, we make sure that they sign a contract, meaning they have to abide to that they cannot share the ingredients and the process of how we make the products, even though they have access to it. They can have access to it because they're the manufacturing team. But in the contract, it stated that even though they have access to it, they are not allowed to share it to external parties. So it's becoming more and more of a critical issue because we are now in the process of transferring all of our data, all of our information to digital systems. But when those digital systems are breached, and of course they can be breached in some way or another, it can be a problem for a company that is trying to protect their intellectual property.
Alright, thank you so much, Miss Nazel, for the explanation and the answer. We're
Thank
we're
you.
going to move on for the next questions.
And this is the last question for Mr. Koshiro because time's going to run out. So I already sent the question in the text box. You can read it and answer it. Thank you.
Okay, so how to properly use AI to prevent misuse and what are the concerns in it happens? And actually, there are many concerns, but what we can do as a user is something like do not input some personal information into the prompt. So like when you ask ChatGPT, please don't use something like I'm Koshiro Saito. I live in Tokyo in Japan. Could you answer something like because it will there will be a concern that the company store your information, and it's not company's fault actually because they want to have the feedback, so they automatically collect some of them, and if unfortunately it contains your personal information, it leak to the training maybe, but actually companies monitoring the contents of training, so the likelihood is not so high. But for users, please do not input the personal information or confidential information. Thank you.
Thank you, Mr. Koshiro, for the answers. Now for the last questions, I leave it to Olivia. Okay, sorry for the miscommunication. That is the last question. So I'm going to thank you everyone for your thoughtful questions, and a big thank you again to our speaker for the detailed answer. This session has given us a clear vision of the technology shaping tomorrow. So So for the conclusion is AI, especially LLMs or large language models powered by transformers, has significantly advanced natural language processing by enabling contextual understanding and natural generation. Yet, yet their limitations such as bias, computational demands, and vulnerabilities in self-attention and watermarking show that continuous innovation is essential to build AI systems that are safer, more transparent, and more reliable. I will say the conclusion from Ms. Nazal's presentation. Every product in our daily life goes through a long journey, starting from raw materials, then being processed through chemical engineering, and finally reaching customers through the supply chain. Chemical engineering plays a key role in transforming raw materials into useful products, while the supply chain ensures their efficient and cost-effective delivery. In the Industry 4.0 era, technologies like automation, LOT, and AI make this process more innovative and efficient, but also bring challenges such as cybersecurity and system integration that must be managed. With that, we finish our Q&A session. And now, I'll hand the stage back over to our wonderful MC, Lovely and Amar, to continue the program. Thank you.
Thank you, Nichiko and Livia. Thank you to our distinguished speaker, Miss. Please wait for a minute. Thank you to our distinguished speaker, Ms. Jian Zaitul Nazal and Mr. Kosiro for the wealth of knowledge shared. And to our moderators, Livia and Nichiko for facilitating such a smooth and enriching discussion. May everything shared today be a source of inspiration and practical knowledge for all of us. Now we will be taking over again as your MC.
Ladies and gentlemen, brilliant minds and future scientists, we've reached the closing moments of the High School Scientific Conference 2025. What an incredible day it has been, from groundbreaking ideas to inspiring discussions. Thank you for bringing your energy, curiosity, and creativity. This event wouldn't be the same without each and every one of you.
To our presenters, thank you for your innovation, your courage, and your hard work. Before we officially end, we would like to express our appreciation to our keynote speaker, Ms. Jian Zaitul Nazal and Mr. Kosiro. This is certificate for Mr. Kosiro and Ms. Zaitul Nazal. The certificate of appreciation is presented in recognition of the valuable knowledge and insight you have contributed today. Let's give a big round of applause. And then I would like to invite Mr. Octaviano Hartanto, our esteemed advisor, to share his gratitude towards to our keynote speaker. Highlight.
Okay, can you hear me? Is it okay?
Yes, we can hear you, Mr.
Okay, thank you. So thank you for the opportunity. As we come to the end of today's high school scientific conference, of 10th Senior High School Bekasi, please allow me to express my deepest gratitude. So first of all, to our respected headmaster, Ibu Dr. Randa Mukaroma MPD and Ibu Liana SPD for their continuous support and guidance that made this event possible. So my heartfelt thanks also go to our distinguished speakers, Koshiro and Zaito, and your inspiring presentations have truly broadened our horizons and encouraged our students to keep exploring the world of science with passion and creativity. And I would like to extend my sincere appreciations to the HSSC organizing committee and all LLC members who have worked tirelessly behind the scenes to ensure the success of this program. Without your work, today's event would not have been possible. So finally, to all participants, thank you for your active involvement. May the knowledge and experience we gain today continue to motivate us in our journey as learners, educators, and future scientists. A short story, uh, I met Koshiro and Zaito when we joined the Tokyo Tech IYC's 2023 short program in Thailand. So that was about 2 years ago. So I know them well as my good friends. They have brought insights in their field. So we are pursuing namely science, yeah, and technology. So I wish them continued their success in the future, and I hope we can meet again in another great opportunity. So, hello, Koshiro and Zaito. Hello, yeah. Sorry for the miscommunication and a little a
No worries,
little
Okta.
about the Zoom meeting, yeah, the participants. So thank you for your time, for your effort during this time. So hopefully stay healthy there. And so as I know, Koshiro's still pursuing the master's degree, right?
Yeah.
Yeah. Okay. Where Koshiro?
Where what?
Where you
You,
pursuing degree? What university?
what university?
Huh.
My university is Institute of Science Tokyo, and actually it's the new name for Tokyo Tech. Yeah,
Oh,
so the
I
same
Oh,
university.
know it.
they changed their name?
Yeah, changed the name and
Yes.
unite merged another university, so changed the
I
name.
see.
Yeah.
Oh, I see. So, okay, success for you. And Zaito still working on the chemical engineering. Yeah, institution.
Yeah. I'm mostly working in supply chain now. So I am doing the what do you call this? So for our company, we're trying to migrate into a smarter planning system. So I'm trying to help my company to do that. So I'm using tools such as Power BI to help us be more efficient in our planning for supply chain.
Well, great. Yeah. So I'm glad to know Koshiro and Zaito progress. So hopefully my students can get this experience to encourage them to uh, uh, move bigger than previous years to become a great person for Indonesia development. So thank you all for the time. Thank you, Miss Liana. Thank you for all. I think that's all for me. Yeah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Waalaikumsalam
warahmatullahi
warahmatullahi
wabarakatuh.
wabarakatuh.
All right, thank you so much, Mr. Okta, for the very warm and kind words. And it's actually really interesting to hear the three of you guys have a conversation.
Yes.
Okay.
You know, Teacher Okta
So,
is a very, very passionate teacher. So I'm sure that more
yeah,
of
he
his students
is.
will be inspired by him as well.
Yes, he has helped us so much throughout this event.
Thank you.
Go Okta.
Yes. Okay. So, before we officially close, we will now proceed with our documentation session. So, we kindly ask all participants to turn on their cameras so we can capture this moment together. I would like to invite all participants to turn on their cameras.
Please open the camera ya.
All right, so it seems like there's still a few people who hasn't opened their cameras. We're going to wait for a few moments until almost everyone has opened their cameras. So I have a few of my friends here joining with us to take a picture together. So those who hasn't opened their cameras, please do, guys. Oh no, they're not shown. Okay. To the participants who are unable to use the background, it's okay. You guys can still turn on your cameras without the background. Okay, so what we're gonna do is we're going to flash the biggest of smiles ever when I count up to 3. So we're going to take a picture together. Are you guys ready? Ready. All right. In 3, 2, 1. Let's try for another pose, shall we? Okay. In 3, 2, 1. Okay. Okay, perfect. And we're done. Thank you, everyone. Thank you so much for participating in the documentation.
This concludes today's high school scientific conference. We hope the knowledge gained will continue to guide and inspire you in your academic and personal journeys. Let's carry forward the passion we have ignited here today. Stay curious, stay bold, and keep asking, what if?
On behalf of the entire committee, we sincerely apologize for any shortcomings and extend our heartfelt gratitude to everyone who has made this event possible. From our mentors and speakers to the committee members working tirelessly behind the scenes. And to all participants as well, thank you so much for your enthusiasm and spirit. We hope to see you again in the next High School Scientific Conference.
So,
take care,
take care
and
and
wassalamualaikum
Assalamualaikum warahmatullahi wabarakatuh.
You guys may leave. Thank you so much, everyone.
Thank you guys.
Thank you guys. See you guys next year.
See you next
Thank
semester.
you, HSSC team, and congratulations
See
for
you,
the
see you
successful
Thank you so
in the
event.
next
much, guys.
Thank you.
It's such a great experience. Thank you so much.